stream today, doing something hopefully inspired by this, like the galaxy. Let me get this window set up. The Android, the Samsung Pickle, the Pixel, the Galaxy phone, like wallpaper. Have you guys ever seen them? Galaxy phones. 8004. Hit me on my hands-free phone. This like very interesting particle kind of abstract stuff. Shaki here. How's it going? Umair, how you doing? The one going moment. So yeah, if you just look at phone or TV wallpapers a lot, there's a lot of really cool like kind of abstract visuals and stuff that they come up with it, and there's some really interesting particle colors and renders and stuff that I've been seeing recently. So I want to try something along these lines. This looks like it's pretty high res. So yeah, it's a really interesting combination of particles, and it almost behaves like a volumetric or whatever, because there's like so many of them. They really like almost scatter the light and the shadows and stuff like that. I'm not really sure what's going on with this one. Looks like you can almost see an emitter here. Zaxbox, how you doing? Greyhound. So yeah, this could be. It almost looks like if you drop ink, pellets or cartridges or whatever into water, but some other parts look kind of noise driven, like non-simulation based or whatever. But yeah, we'll just go ahead and get started with this scene today. So let's save this directory in the stream stuff, where you can share the scene file as we go along. You guys can keep up. This is the 24th. '66 Emily. Welcome to your first stream. Good to have you on board. You found a nice example? My internet is like 1990s. It's a very slow loading today. Yeah, these are some cool ones. This is almost similar to the PlayStation launch, the way that this shader is set up with like a incandescent and specular hybrid or whatever. These are really nice. It's almost like a powder or grains or something like that. Yeah, this is a really cool one. This is almost like, if you guys ever use the Krakatoa, it's like an old 3ds Max plugin. It's like ThinkBox made it. I guess they have made it for other software packages as well. But yeah, you could do tons of particles with it and get a nice volumetric scattering look with that as well. Really nice light absorption, attenuation, that kind of stuff. All right, what are we going to call this? Particle. Getting doubled audio. Is everyone seeing doubled audio? Or maybe you've opened up several tabs. You got it booming through the speakers. We'll just call this particle play. To other people that look like they have good audio, maybe you have it on multiple sources, multiple browsers, incognitos. All right, so let's make a sphere. The remoted. All right, so we have the sphere, and we'll do points from volume. This is just a quick way here to get it any shape, fill it with particles. By default, it will do them evenly spaced out, so you'll get some weird like moire, somewhat artifacts or whatever. If you just want a more organic shape, you just increase the scale to 1. That will just randomize them enough. 1 unit, this is like automatically scaled to the separation. So jitter scale of 1 will always just evenly distribute them to a cloud or whatever. Like if you go beyond 1, you're doing like breaking the silhouette and stuff like that. So yeah, that's pretty cool. Particle cool zone. This Android? Yeah, I was looking at that earlier. Wilhand. Let me get it up in, as well as like a little reference, so people just joining can get an idea. Just put this window here. All right, that sounds good. Your sound seems a bit closed. It should be good, right? How is it? All right. So that's a good idea. Then we have a few different ways we can move these particles around. Attribute VOP. This is a really useful way to add noise to things. Usually, I'll do my coding the typing way, like with wrangles. But when you're working with a lot of noise functions, doing them in a VOP can be a little bit easier to comprehend. Steve GH, good to see you. So you're doing them in a VOP. You can like mix and match a lot of different noises. You can kind of composite them very similar to Nuke, how you would composite like many different images. So you could multiply, like add, and there's even a composite node that has some of the compositing operations of like XOR. Like these are kind of Photoshop terminology or whatever, like soft light's a Photoshop term. But if you really want to get interesting with it, you can do a bunch of things. Like if I were to script this out in a wrangle, you can look at the auto-generated code if you just do view vex code like this. But it's very quickly like very cumbersome to visualize or to like think of what you're doing, where you could lay out things pretty easily here. Seagull Rush. So like Nuke, I'm in a mess here, but like Nuke is just very visual operations of what the colors are doing and looking at masks and things like that. So like working the same way with noises in VOPs is sometimes preferable to wrangles. Do you use Python as well for some things? I'll use it for kind of having Houdini communicate with outside of the program, like with files on disk, databases, and that kind of stuff. But inside of Houdini, I'll mainly stick to Vex because it's more optimized for large data sets. Like it will multi-thread. The performance of it is definitely much better than Python if you're working with like millions of points and things like that. So we'll just have noise and we'll add it to the point position. Boom. Look at that. We're done. So this is super simple, super easy. Let me get my reference image back up here. So there's definitely some more complexity going on. We could do something here and like mix and match noises. So I'm going to plug this one into color for right now. And I'm going to leave this generating a one-dimensional noise, or just a single grayscale value, like a black and white float. This one-dimensional basically means one channel, like an alpha channel, essentially. So we can remap it or fit this range. And this will let you kind of like clamp or change the range. And then I'm just visualizing this in color, in the color channel, but we could multiply right here and use this as a mask, or more like an alpha channel. So let me get it out of the color now. Now what we're doing is just selectively noising or moving or like advecting particles based off of the second input or the second noise function. So we can add a little bit more interest or just you can kind of see here they're like chiseling away or chipping away sections of the noise. We can do some similar stuff like that. Deepak, after 5 months. Yes, I'm getting back into the habit. I don't have a set schedule right now, but I've been switching my streams to earlier in the morning just to get them in before work, just to try to balance things a little bit better that way. So I'm just increasing the particle count right now. If you press the D key over the viewport, you get this window, and you could go to geometry and do like particle size to visualize different densities or different thicknesses of particles. But yeah, I'm doing well. I'm looking forward to hopefully getting even more streams going. I've been doing like one a week so far, I think, for the last couple of weeks, but hopefully I can get some more going. I have some interesting stuff I want to cover. Let's see. Let's try that. And then if I ever change the frequency of these noise functions, I usually use this multiply constant. You can go in here and use the middle mouse button to change like the frequency along each axis. But if you do it ahead of time here, maybe you want to make this a higher frequency. You can just visualize it. Like I know that I'm increasing the frequency by 4. It was like 400%, instead of having to click on this node and look at the parameters. And then you can always like turn it on and off and stuff like that. So it's a little bit more complex visually, but I like that kind of, I don't know, like visual signifier or like reminder or whatever. All right. This is pretty cool. And another thing I'll do sometimes is like this vector to vector 4. So when you first plug it in, like it reverted me to a one-dimensional noise. So that's why we got everything pushing in the same direction. I'm going to go back into 3D. And the reason I do this, or the nice thing that this offers, is you can do a noise function in this fourth component. Boom. And it's kind of hard to see there's like a lot of other stuff going on. Let me just bypass this. We could turn this off for a second. So what this does is kind of distort or evolve the noise. And it just gives you an extra level of complexity. It's kind of like a warping or distorting the domain that the noise is in. If you look at, I think it's just called domain distortion with Indigo. Domain warping. He wrote a pretty interesting article about this. So visualizing this stuff like black and white, this is doing the same technique here as evolving the fourth component, I believe. Or he might just be adding noise right here. There's similar ideas as you get a nice kind of like abstract painting type of effect. You did a O noise inside the geo wrangle. But how do you make the noises on the point wrangle on the geo and apply its attribute to the constraint? I'm not sure that the second part, how do you make noises in the point wrangle? I'm not sure about constraints. If I ever want to recreate these noises in a wrangle, you can right click here, and if you do view vex options, or I'm sorry, if you just do typed properties here, and then you look at the code section, you could see the actual code you would need. Some of these are a little bit more complex because you need to include these libraries. But if you wanted to recreate this noise in a wrangle, you could like copy and paste this stuff and get going that way. I think like this, if you look at just like the periodic noise, you can see that they use the X noise and noise functions and stuff inside of it. So if you're ever really looking to do this stuff inside of a point wrangle, you could figure out what's actually going on that way. And any vex or any VOP node, you can do that. So even I think with this, maybe the add is a little bit too simple. Maybe this this one even here, you can see like the snippet or the vex code going on. So yeah, we're warping the stuff here, and let's do another. I'm going to go with the lower frequency this time. And then sometimes it's nice to move some of these noises, like offset them from the origin. Can avoid some artifacts or like visual things like that. If all of these are running like exactly at 0, 0, 0, you can get some weird origins, like artifacts at the origin. It might always be like 0 at the origin, and it can make things look weird. All right. This is pretty cool. Another thing you can try is like the curl noise. I'm just going to replace this section with it. And usually I switch to one of these analytic noises. We might need less power or less amplitude. Get something around a similar range. So curl noise can generally give you more of like a wind type of more natural looking effect. I'm just adjusting the form here, trying to like balance all my different frequencies to get a nice composition. SM7B, you're talking about the mic, Steve? It's SM57, I think. This one? It's a pretty good mic. It's pretty durable. You could like knock it around. It's definitely not like the top highest quality. But it's pretty good for the money or for the price or whatever. All right. So yeah, we're starting to get some interesting formations and stuff peeling off. Another thing I might do is like, while these particles are all still at the origin or before we move them around too much, I'm just going to use a wrangle. If you want a nice way to boost, ooh, I might need one of these. Yeah, my microphone setup is pretty crappy right now. I'm just using, Shure makes this like XLR to USB converter. So I just have my microphone plugged into this, and then that's plugged into the computer. So it's like, I definitely could use some more work. Yeah. Yeah, I think I can turn on phantom power. I could definitely use this because my OBS, I'm already like in the gain, like I'm artificially boosting it or whatever. Yeah, I'm also looking into some VSTs or plugins or whatever to help out as well. There's should be some better like post-processing ones. All right, so we'll take the color, and if we set it to the length of P, this is going to be like the distance from the origin. So it doesn't look like too much has changed, but basically like where it starts out close to 0, it will be black, and then it will get brighter further out. If we want something a little bit more interesting, we can use that grayscale value to drive another noise function. So when we do that, now we get a colored, kind of like randomly generated like color fall off. And you can multiply position like I was doing inside of the wrangle if you want like higher frequency to compress the amount. But even this is a pretty interesting natural like fall off we're getting of natural, I mean, is like warmth, like warm to cool or whatever. So yeah, this is pretty cool as well to maybe try it out. And we could do an initial file share if you guys want to start playing around with this. You can pick up the scene file and like follow along or anything like that. I know I've already kind of made a bit of a mess inside of this bop, so it's rather than recreating and following all of these parameters yourself, it could be a mess. So you can just grab the link, or if you do !hip, we have some shelf tools and stuff like that that you could click if you want to manage things that way as well. So we're working with 250,000 particles. It's a little bit lightweight. This kind of thing here, this might be easily 1 million. It could be like 10 million particles. So we want a bit more to get up to that level of like accuracy. How do you dynamically grow hair in Vellum? You set that up inside a Vellum solver. Usually people won't dynamically like change the particle count or topology inside of Vellum. The solver doesn't necessarily like that. I think what I would do, Deepak, with your situation is start with hairs like a really small length, and then allow them to grow after a certain frame or time or something like that. So there's some things you can do. I've even, if you do !resources, and then if you just go to the Vex tab of my website here, this is like a little cheat sheet I like to use, and I have started documenting some of the Vellum constraints, the Vellum attributes. I might not have. Okay, so .vellum attributes, and then there's collision ignore, and or you could even use like disable self or disable external. There's ways to glue or pin to animation. So basically, like the hairs that you wouldn't want to grow yet, I would still have them in Vellum, but I would have them really short, like shrunk down, and then collisions would be turned off. You can turn off like external forces. You can do a bunch of interesting stuff that way. So they're basically like, the solver knows about them, but it isn't doing anything. It just is ignoring them. This is also the same technique that I was kind of using with on YouTube. There was this tutorial here that I did, just the grain character disintegration. It does a similar thing where it kind of looks like you're emitting or creating particles throughout the simulation. But I'm basically just switching them from parented and ignoring like collisions and all that other stuff into the simulation. So I would do that same type of technique, instead of trying to do like creating hair over time, if that makes sense. All right, we'll get back. Just make that a little bit bigger. And I'm not really liking, there's like a little bit too much, it's a little too busy, some of the form. The color, the one reason I did this color is because it definitely helps you read. Like you can tell what's going on a lot more with your three-dimensionality. Without it, there's no lighting, there's no shadows or anything like that, so it's harder to tell what's going on. It's the same thing they're doing here. If you didn't have these color differentiations, this wouldn't look as interesting or whatever. All right, so let's figure out what's making like this so wavy. Could be the roughness. So roughness kind of acts like a frequency. The more roughness you add, the more layers of noise are being like stacked on top of each other. That gives you that like very squiggly kind of look. Some edges are too hard. It could, with mine, there's definitely some hard edges, but also with this, there's some hard edges. We'll see when we start rendering what happens with it, but it can be nice to give you some contrast or stuff like that. See if we like it when we get to that point of time. Yes, kind of spiky. It's kind of nice. So you do it this way. Another thing you can do if you don't want to, you want more control over things, you could do like this vector channel ramp. And this will create a color ramp. So a little bit more art directable. We make the red to blue. You can multiply this, so you can work with it different ways as well. So this just allows you to art direct things a little bit better if you want as well. So I think this stuff here we'll probably just want to go to, don't even need a multiplier, because this sphere is a uniform scale of 1. I'm just going to change this here so we have something kind of warm going on with the core, and then we'll just go with this like it's a little bit easier to control this way instead of relying on like a noise. Okay. Let's try that. Might do like a power, like exponential. I don't know about that. It's a little too crazy. See what happens if we just add these. You kind of get lost of dialing or adjusting values or whatever with this all day. So I'll try not to do too much of that. But It is quite important though, because it's like you're just trying to come up with an interesting silhouette or form that this stuff is making. So it does make sense to really spend some time. But it is, if you're on like a timeline or something like that, it can be easy to get lost in the sauce, as it so is. All right. So I'm kind of liking this formation. The ref kind of looks like it is adding a constant vector based on the noise. Yeah, I did kind of realize that. At some point, one of these got reverted back to a float, the 1D noise. And then when this casts it back to a vector, is basically doing everything like 1, 1, 1, pointing things in that direction. And there is a little bit of that happening in the reference, I think. So if we really want to get, I wasn't planning to really like go 1 for 1 to match this, but if we want to add a little bit of that look in, you could as well do like a constant. So this would be your direction, like this. So if you multiply your direction by this amount, we could also add this in here. So let's say maybe just move things up. This thing, I'm gonna make it higher frequency. Maybe not as much. You can start to add in some of that look as well. Fran Zushik, how's it going? So you can get maybe a little bit of that. I don't know if I'm doing too much here. It's like if you add too many noises together, you kind of will get like some blurry stuff, or it's a bit of a mess. Let's go with a lower frequency. That's definitely one option. Another thing you can do is maybe if you do this like ahead of time to the position, you can get an interesting effect that way as well. It's like not as noticeable. Like this is super noticeable. But because I'm doing it like to the signal or to the position ahead of time, it's not super obvious what's going on. I don't know. It's kind of an interesting experiment. It could be kind of cool. It's kind of like a brush stroke. It's possible. Let me see if I can. So lost right now. What's the best way to do this? Just watch and then try to get it right when it goes to YouTube? It depends. Whatever works best for you. We kind of have people of all different skills or levels of Houdini. If you're just starting out with Houdini, it could be definitely I move a little bit too fast. As I go along, I am doing these. I could do another one right now. These incremental file shares. So you can grab these and get caught up. But if you're starting out, I think you definitely might need to do these a couple run-throughs or try them out a few times to really figure out what's going on, or get your mind like wrapped around everything. Hopefully that helps. All right. Okay, so I think maybe if I do a fit range here, you could get like this kind of look going on. I think that might be what I don't know, a portion of what they did, so that it's not like unconstrained randomness. This will let you work within a range or whatever, so it's just like punching the value just in certain locations, if that makes sense. You get a little bit more interesting stuff going on that way. Ginger VFX, thank you for the raid. Oh my God. Welcome all the new raiders. We're in the Houdini zone right now, making some particle kind of abstracts. Ginger VFX, I haven't seen your stream. What kind of content do you what kind of VFX content are you interested in? Houdini. Maya Houdini Nuke Mari. This is very professional, very high level. This is like the elite tier tool set, pretty much. Like every big VFX studio will basically, this is the core of their pipeline, almost, yeah. So yeah, I do a little bit of Nuke. I'm just using it like a lazy artboard style here. But I was using Nuke a lot more in VFX. Like I even started with some compositing when I was first getting into the industry. But yeah, we're just making some interesting particle patterns. Could start to get into rendering right now and see what happens. And as I go along, if you guys have Houdini installed, I do distribute my working scene file or whatever. So if you just grab this link, or you do !hip, there's some scripts or shelf tools or whatever we have to assist you in managing that. But if you guys want to follow along, like in real time, you can do it that way. Or if you just want to watch and see what happens, either way is good for you. So I'm going to go ahead and just control click on the camera up there, the camera shelf tool, to make a camera. Usually I switch this aperture to 36, and then you're working more like a traditional photography lens length or whatever. I'm more interested in like this area up here. This looks like we have some nice layering or stuff happening. So I'm just gonna frame that up. We're working with almost 4 million particles right now. It's pretty lightweight still, if you really want to get to this high quality. I'm just going to reduce the particle separation so we have a little bit more particles we're working with. So we're almost at 20 million now. We're getting pretty close to like high level. All right. So I think we could start rendering. The only thing I'm going to add is just a p-scale attribute that's just going to determine the size of the particles. So say p-scale. We'll do 0.01. If you want to visualize the p-scale, yeah, with specific viewport settings, notice, if you press the D key over the viewport, I changed this particle size here to kind of visualize things. And if you add a p-scale attribute, instead of display particles as points, if you go to disks, this might be a little bit slow with all the particles, but this will actually visualize this value. So if you want to directly visualize the p-scale as you change it or whatever, you can change this to disks. It does get pretty slow with millions of points, but you could also do like pixels or other things like that. And then this anti-alias samples, it will be hard for you to see with the video compression, but you just change this as well to kind of like smooth things out. Okay, so we do attribute vop p-scale, and we're ready to render. I'm just gonna make a light and just drop one in and see what happens. So we'll put a area light right here. So we're doing this kind of like 3/4 like rim light business. And let's get a render view going. This will automatically create this mantra render settings. It looks like it's using the camera I've given it. I'm just going to go turn off the exposure, and then I'm going to disable attenuation for this one. So I'm not really interested in making like a realistic scene with the light to fall off in a realistic way. I'm just more interested in creating like an interesting looking abstract kind of visual. So that's why I'm kind of cheating or whatever. So this attenuation is basically the fall off of light, and I've turned it off. So it's just going to be constant light just hitting this thing. No redshift. Not today, not right now. So yeah, the reason I'm not doing redshift is once you start to get into crazy high particle counts, it could get a little bit slow on the GPU. And we could go ahead and make it now. There's a pretty interesting mantra shader that you can use with particles. So I'm just make a fresh material. Can I do it? I think it got assigned. So yeah, we can just go in and directly make a nice little shader here. So particles, like if you just want to get the surface color, there's a node for that. And you can do point color. Can you get the additive effect like in Krakatoa? Yes. That's exactly what we'll be doing. So we just do this, and we have a constant shader. We've basically replicated the viewport. If you do constant right here, you can adjust the OF. This is like the opacity. See if I hover over it, it says surface opacity. So we've set it all to 0, which is basically fully transparent. But if you do some value kind of halfway or whatever, then you start to get this nice like additive color brightness or whatever. If you don't want things blowing out like that, sometimes what people will do is like this pre-molt setting here. So that would just keep things like in your exposure range. There's an option to have. I'm going to turn that off for right now. If you want to start adding in, like we're not taking into account any lights in our scene right now. If you want to take that into account, you can use this lighting model. And then if you switch this to isotropic volume, this will give you kind of like the Krakatoa, like scattering, light scattering, shading this is how you can get it inside of Houdini. So if you do compute lighting and you plug in the BSDF and the color you don't need to worry about. This BSDF will take it into account. So we can just wire this up like this, and this. So we start to get like a more volumetric kind of scattering stuff happening. We can put our OF, or the opacity, back in. And now we start to get some really nice light, kind of like shafts of light happening and stuff like that. And then if we want the color, just multiply the BSDF to tint or to apply any color. So we do that. Before I keep going, another thing we can do, I'm going to go pretty low with the stuff to get the light really scattering. Might even want to go super. Get some really, it gets slower to render, but you get really nice, like almost like a white water or something like that, like frothy kind of look. I might make my particles a little bit smaller. So again, instead of just adjusting the opacity, if you adjust the size, you'll start to, the shadows will get like a little bit deeper into everything as well. Let's go down a little bit more. And if you want to also get more into the Krakatoa look, right now, the opacity is just a float value. Krakatoa was so fast with this stuff. Yeah, you can make it a little bit faster inside of Houdini if you switch this to a VDB. We could maybe go into that, but I don't know if we'll have enough time today. So yeah, that's one of the reasons Krakatoa could do it a lot faster, because it was like doing a little step for you behind the scenes of rasterizing everything into a volume. You can do the tools with Houdini to do that. Let me just switch this here. Let's do a color. Just reverse the inputs so that the color is first. And if we start to do a color, then you can see we get a nice like attenuation here. So you can get a kind of like Krakatoa type color fall off that way as well. You get like interesting, I think we could speed this up a little bit. Let me turn off that. So usually I'll turn off ray variance anti-aliasing with particles. And I would just do like primary samples, and that can help speed things up as well. All right. So we can include even the particle colors. We kind of have too many things mixing around right now, like too many colors being applied and everything like that. So it's just get a little less saturated down here. And I might have to rethink like my lighting. If we keep an eye back on our reference, this is very well lit. We might even want to add like GI or something like that. We're super dark. We could go like a dark variant right now, but I think maybe we'll just try GI. So we'll just add the environment light. We could even do render light geometry if we want the background and everything like that. Let's take a look at the particle size. You think maybe we want these, we're pretty close, right? Yeah, I think we're pretty close in terms of size. So let's take a look at our settings over here. I'm just going to make a copy of this existing stuff so we can try out some new stuff over here. We could go back to these if we really figure out something, if we really lead ourselves astray. So I'm going to following here, but kind of lost in the surface color of the material. So the surface color, real quick, if you look here, I've just checked point color. This is a digital asset. If you go inside of it, you can see how it's built. Basically, if I just Control C and copy that and paste it here, this is the same thing. This is all that I'm doing, is just getting the CD attribute from the points. Or it's basically the same thing in Redshift as the particle color attribute. No Redshift for this one. I think Mantra, there's still some reasons to use it, especially if you're just doing stills. You can get really nice self-shadowing and volumetric looks that, I don't know, sometimes I've struggled to get this level of detail with Redshift. I kind of really like this shader, the isotropic volume shader. And if we want at the end, or if we really get something that looks nice, we could always try like a Redshift challenge, kind of put them head to head or whatever and see what happens. But I've used this shader here for really nice effects. Let me see if I have something hidden here. Mystery. All right, I think I put it away over here. No, where did it go? Can't have additive material in Redshift, as far as I could tell. I think you can. It just depends how you set it up. But I've definitely done additive shaders inside of Redshift. It can get pretty slow to load a bunch of particles, which is why I'm not doing it right now. Let me, trying to look if I can find that real quick. Do you plan on doing any projects in Unreal? I haven't really learned too much Unreal. I've used it in some projects before, but I haven't kept up with the new versions. It could be fun to do in the future, but let's just keep going with this. I'm getting sidetracked a little bit. I could try to find it later. I'll try to post it on the Discord, but you can get some really good, we'll just go ahead and try to do it right now. You can get some really good, cool effects with this Mantra shader. It might depend on the additive style that you're thinking of. You can definitely do additive rendering with Redshift, but it's possible it's just a little limiting in terms of the style, like that the additive like absorption stuff I was doing. Maybe you can't do that with Redshift, but simple opacity like additive stuff you can do. Shaki here, you've increased the count. Yeah, I'm pretty I'm at almost 20 million right now. I'm still going back now, and I'm gonna sculpt the noise a little bit, but it could definitely use some more particles. I agree. So I'm just trying to simplify stuff a little bit. Like my colors here, I think were a little too busy, and then the noise as well was a little too high frequency and stuff like that. So maybe let's just eliminate. Could change stuff a little bit too much. Let's just eliminate that. Yeah, the color like absorption or attenuation, it might not be exactly the same with Redshift, and then with volumetrics, like the color scattering or that kind of stuff. You can set it up with, if you look at like the Milky Coffee preset or some of the transmission and refraction settings, but it's definitely not like ideal with Redshift, I would say. Like Arnold or Mantra or even V-Ray, I think you have a little bit more flexibility. All right, so I'm just gonna rip out some of these other noise functions. I might try doing this stuff in a feedback loop. See what happens. You might be doing a little bit too much. So if you do the noise in a feedback, you can get crisper features. So what I'm doing here is recursively running the same noise 10 times. Each time it moves the particles slightly. And the reason to do this is because like you'll get better accumulation of stuff. If you keep rerunning the noise functions again and again, instead of just calling it like once and moving it 10 units, if you incrementally move it like in smaller steps, you can get nice results. You are not going to use Redshift in this one. Right now I'm just setting things up with Mantra. Like I said, if we get some really cool looking results, maybe we'll go back and like compare them side by side and see what happens. See if we can match the look with Redshift. But for right now, there's a certain shader that I've used quite a bit in Mantra. That's why I'm sticking to this. I didn't know the chat was so set on Redshift. So it's taking a second to load. So this is starting to see it a little bit. But you can get really nice, almost like a painting. Really cool color effects with Mantra. What's the difference between a for each loop and a feedback loop? This is when you do it through the tab menu and you type in feedback. This is doing a for loop, but instead of running like over a bunch of things in parallel, this is saying by count, and then it's telling it to feedback or to keep repeating the end result. So this runs the noise down here, and then the feedback means like return the result. So it just keeps recycling this node like 10 times, if that makes sense. Yeah, I can do another file share. So you guys want to get caught up. There you go with that. Yeah, it's rerunning it with the same data 10 times. But you can change it here and do more iterations and make it. You'll start to get stronger like features if you do more iterations. If you do too many, you kind of will get like some crazy strings maybe or something like that. I think another issue that I might be having right now is like because I'm a little bit cropped in on the particles, I'm kind of like not utilizing them as well as I could be. So if you zoom out, then you don't have to worry about like deleting or cleaning up other particles. So I might zoom out. Let's reduce these iterations. I'm gonna do a lower frequency. Ooh, this one could be nice. Some interesting things are starting to happen here. All right. This could be cool. So my reason here to reduce the frequency and reframe things so I could basically like fit more particles in the camera view. That should kind of give the impression that I'm rendering more particles, if that makes sense. All right, guys, I found it. You guys ready? So this is using this similar shader that I've built here. You could get some really nice kind of like shadowing and stacking and stuff like that going on. This is based off of a fluid simulation, but it's using the same shader. So you can see some particles and the shadowing and stuff like that. So you can get really nice looks for sure with this shader. I don't know if you could render this many particles with Redshift. So there's one reason to do that. All right, so we might be getting a little too gnarly here. Too high frequency. So I'm going to reduce my iterations here. Fibrous. Yeah, it's a little too, I think I'm just getting too far away from that. It's just too busy. It's like, this is pretty nice in its simplicity or whatever. So we could maybe reduce the turbulence. This distortion here that I was talking about earlier is definitely having an effect. So we could try something like this maybe. Let me increase this point separation. And this is just going to let us work a little bit more quickly. So this could be an interesting one. let's see where we're at. All right, so we're definitely getting a little bit more simplified, maybe a little bit better. It's less busy or whatever. I think this is shaping up to be a little bit nicer. It's always like a balance of detail. You only want high detail in certain places and not everywhere. If you do it everywhere, it's just like a fuzzy mess or whatever. Let's think about this. Let's get back into our light. And I don't know about this environment light. Could try it without the main light. This is just pure kind of like ambient lighting. I think it's nice to have a directional light. This is looking a little bit nicer. I think we want our particles a little bit bigger. And I don't know if we want to mess with the colors too much. I think this is like pretty cool. I'm not the best at color theory. I'm gonna try to get something a little bit better. This is always a cool one to do, is like red, blue, or whatever. It's a very commonly kind of used gradient. So yeah, that's pretty nice. Houdini colors? Is this the orange black? Those are Houdini colors. Sometimes afterwards I'll just go and nuke and do the hue shift and mess around with things that way. But yeah, I could try another color thing in a minute. I might actually get rid of this environment light. Let's do this, and let's put in just a fill light over here. So this light, I'm gonna make it pretty big. And let's try something like that. If you want to keep the background white, I think one thing you can do is like light enabled render light geometry, but in your, maybe in the categories, like you could set this light to be in this ignore group maybe. And then in my particles here, if I go to light selection, I could do like everything accept that. Oof. I don't know about that. I'm missing my redshift. It's easier to set up that way with redshift, I think. I don't know about this. I'm getting off the rails here. I'm just gonna leave it. My environment light turned on. I'll just turn it down a little bit. All right, so we're getting something pretty cool so far. Let's go back into here. Make everything a little bit more transparent. Nothing about rendering in Houdini. Is that also set up in the scene file? The mantra setup is in the scene file. It's a little bit tough to get up to speed, I think, with rendering in Houdini, just because the learning material for it is a bit of a mess right now, because they're switching to Karma, like slowly but surely. And then there's like USD and LOPS and that kind of stuff. So it's definitely hard to find all of it, but this is the rendering setup right here, and it's pretty simple. And yeah, it's just all inside Houdini, no plugins, no third-party things needed. All right. So we've got a pretty nice shape so far. And we're not using too many particles, so we could go higher with our particle count. Get some more detail and stuff that way. Let's get back into the camera. Yeah, Arnold is pretty nice. It's definitely kind of slow, but it's pretty good for rendering particles. I have it installed, but I don't have a license, so I just use like the watermarked version or whatever. But yeah, it's definitely, it's a good thing to have. So I think also these colors, one thing I'll do, if you hold shift and click on both of them, you could switch them maybe to Bezier. Did this switch? Yeah. So I'm trying to get a better like in between. Sometimes I'll drop in another color point. But basically I'm trying to avoid this like muddy in between color here that's very, not very saturated here. So if you just crank that midpoint to a higher saturated color, you might even want to leave it like closer to red for a little bit. I'm just trying to get more, get out of this muddy range right there. I don't know about Bezier. Sometimes I switch between that and the monotone cubic. So yeah, this looks like it's preserving my saturation stuff a little bit better. Could try yellow in between. I'm trying, I don't know. I don't want to have everything too busy. We could try this and see what happens. So we're at 15 million particles. Let's see how these look. It's a little bit better. I think I need to reduce my iterations. Started to go a little too crazy with that. And let's just stay in this range right here. This is like too too squiggly. I was getting too messy again. So I just reduce the number of iterations of this feedback. That will keep things more controlled or compact. All right, this is pretty cool. This yellow, I think, is not helping me out. Let's try a different. All right, this is a little bit more interesting, I think. That's good. Let's go back into the lights. I did rotate the camera around, so I think we need to relight this stuff a little bit more. So this is a nice, better kind of rim light. More interesting. This is like the fill. So you have rim, fill, and then this is just like environment. So I cranked up the fill. It's a little bit more interesting. Whoa, it's too much. All right. So this is starting to look a little bit better. Let's dial back the size. So I'm just reducing the P scale. So as you reduce the P scale, you can reveal some interesting motion or detail or stuff on the insides. Can be pretty cool. Ambient lighting or shadow color to blue instead of black. Yeah, that could be helpful. So I've reduced my P scale enough. I think that's definitely, I kind of started to get it there. You could as well do it on the light, I think. Shadow, or maybe reduce the shadow intensity. That's one way to do it. You could also, I don't know if this will work, but that is a pretty helpful tip. Another thing you can do, this might make things a little bit more slow, but on your mantra node, I think if you increase this volume limit, you'll start to get like indirect volume illumination. Might get things too slow at a certain point, but if I make a snapshot of that frame and then go back and turn this off, so as we switch between those two, you can see that's giving me a little bit more blue in the shadows as well. But yeah, I think that's a really nice advice. Benjamin YDE, Benjamin Yid. But yeah, having some more natural like bounce light or whatever is pretty cool. So yeah, we could leave this volume light turned on a little bit. Sometimes as well, I turn off the stochastic transparency. that can give you like nicer, preserve kind of the color attenuation a little bit better, but it definitely slows things down quite a bit. So let's just make a compromise, and we'll just leave volume light bounces turned on. And we can as well play around with some of this stuff. So I'm just playing around with like the overall transparency multiplier right now. Maybe just go back in the camera. What do you guys think? I think it was getting framed up pretty well. Kapow. This is pretty interesting here. Full frame. This is a pretty nice composition, like a zigzag kind of thing going on. So let's save this. We'll go up another version. Do a scene share if you guys want to pull this in. And we have a little bit of time left. Could talk about some different ways to render this. Perfect for a desktop wallpaper. Yeah, so the idea here is coming from this, based roughly on this phone wallpaper or the Galaxy. But yeah, for wallpaper and stuff, it's a really, really nice idea. So yeah, I think, I'm not sure which studio or anything did this, but there's a few different directions they kind of went into. Is this particles? So yeah, there's different levels of like turbulence and stuff like that, but it's fun to play around with. This one's pretty cool. I think it's particles as well. So I don't know why it's hard to find such a high res. These are all like so pixelated. The hell is going on? Some particle blurring. Yeah, you can make some bigger than others. You could also add depth of field for blurring. That could be nice. Trying to think right now. So if we want to, let's try to add a little bit more detail here. We could increase this particle count. I'm going to reduce the particle separation up here to do that. We're at 43 million. And if we look at everything here, like our camera, we're not framing all of the particles necessarily. Sometimes what I'll do is with this volume node, you can build a volume from the camera. This is a volume based off of the camera frustum. So once you expand this out, could we try to do a shot from inside the particles? You can. One thing you'll realize is the quality kind of breaks down. Like the detail breaks down very quickly as you get in close. Let me build this camera first, and then we could try it. So if we look at these, and if you just do volume bound, this will build polygons from your camera. So what we want to do is crop the particles. If we cut out these particles down here, we can optimize the render a little bit. You just do group. We want to group points. Or we could do it based off of the volume. And let's increase this divisions. And let's just try this with a blast. Group 1. So I think we need to set our ISO value just a little bit above 0. And then if you want to add some padding, usually I do that so that it's leaving a little bit of it's not cutting it right at the edges. Otherwise you get some like bleeding, the shadows or whatever, the light will bleed in. So let's just add our padding. All right, so you could see here as well, you just have some extra space. So we're optimizing things by cutting out like 10 or 13 million particles. If you do want to get closer, you could definitely try that. I don't know how close Zach's box you're talking about getting. Like, this might be an interesting region. But from my experience, this stuff, like, you might need to build a much more advanced system to add like another layer of noise and like crop in on that region or something. Could we get that kind of curve? There was some stuff I was doing earlier based off of like a single direction to move things, kind of like a mask or whatever. It's possible. I didn't want to completely copy this one-to-one, so I didn't like fully pursue that. But if you look earlier in the stream, there were some techniques we talked about to get that kind of like masking or whatever. Yeah, the shallow depth of field, that's a really good idea. So if you're trying to preserve detail or like implied detail or whatever, if you blur out this stuff, that can give you some better stills for up close. Denoising, you can. I try not to, especially if I'm just doing stills. The render times shouldn't be too crazy, but it's an option for sure. There's like, I think if you go up here to render, there's the download NVIDIA Optics denoiser. There's some other denoisers and stuff. Yeah, the spiky curve, this kind of stuff. So there was things there was stuff we got to that was earlier in the stream that was closer to this kind of like we were talking about just adding a single vector and displacing along that. But like I was saying, for my final result, I don't want to completely rip off their composition and design and stuff like that. So I'm working a little bit differently. Let's get back into the main camera. Need 10 times more particles. Yeah, this is kind of what I was saying. When you get closer, you realize you need more particles. You can definitely crank some of these settings a little bit higher, but for the just because I'm doing a stream and trying to work quickly, I'm not really pushing everything to the limit. So let's go into the depth of field stuff. If I'm setting up depth of field with mantra, one thing that I usually do is turn on under extra image planes the shading depth, and then under rendering, if you just enable depth of field. So if I go to position Z or Z depth, this should give you, if I press the I key over the view, the M-play, the render view, now I can see the actual distance of the particles from the camera. So you can plug those numbers in here to focus distance, roughly 60. And maybe f-stop is a little bit more shallow. I've used Karma a little bit. To me, it's still kind of in beta, where they're still working on some things. So I'm sticking with mantra for the time being. But I think it's definitely promising. I think they're working on adding GPU support for it as well, which could be pretty nice. So I think let me see, my focus distance might be a bit off. So you can visualize the focus distance as well if you zoom out, I think. So I think because I'm rendering transparent particles, I think my Z depth is a little bit messed up. Vegan Nuts, how's it going? A renderer that doesn't support GPU? I don't think any of the mantra, the Houdini built-in renderers support GPU, unfortunately. All right, so it looks like my depth of field is working a little bit better now. Let me just take another look at the lighting. I think I want my rim. Just crank the rim light up a little bit more. So we're definitely getting some nice depth of field. It might be too much. Let's go a little bit less shallow of a depth of field. Then I'm going to redo these lights a little bit. Let's drop these other things out for a second. Gonna buy Redshift soon. It's definitely a good investment. Super useful. I think if you're especially just working, like, you don't have access to a render farm or anything like that, it's pretty nice. So I'm trying out some new light directions. This could be interesting, like a darker vibe, darker scene or something like that. I don't know. It's getting a little bit messy. Spent the whole morning updating version of everything. Yeah, once you get a lot of plugins and stuff, it can be a task to keep everything up to date. All right, so we're in a interesting place. I think we can get a little bit. I think we can get a little bit more out of this. So I'll just save this again as another version. Usually if you plan to make like substantial changes, if you copy your nodes or you version up, then it's a good way to make like a checkpoint or a save point. I use Blender very rarely, a couple of times a year, like cycles or there's the viewport renderer, who's it, Eevee? There's definitely some good features in Blender, but I don't know the procedural aspects of it or like simulation aspects of it enough to use it that much. All right, so we can try some new settings here. Just gonna go back into my camera. Let's get out of the cropped volume stuff. So I'm just gonna try out some stuff and see if I can get things looking a little bit more interesting. This could be nice. John's back again. Yes, I still need to update my schedule and stuff like that, but I've slowly been getting back into the streaming habit. So yeah, if you really wanted to get closer to the reference, like I think this type of thing could be the way to go. So I've basically replaced my vector noises with this. Is it Steve? Steve had a good name for it earlier. I don't know where he went. It was like it's like a single vector direction, constant vector, yeah. So we're basically defining a direction. You could change it as well, like diagonally or something like that. If you are cranking it, you might want to normalize it. Let's try things this way. So I'm going to add some of the curl noise to it. Ooh, pretty cool that way. So it's slightly broken up constant vector now, and that could be nice. This is kind of cool. It's more like a ballistic. Lokesh, how's it going? Vitamina. Yes, sorry you're a little bit late, but yeah, we're getting close to wrapping up here, maybe like 10 or 20 more minutes. But yeah, I've been just rendering some particles, using these like Samsung Galaxy images. This one looks kind of high res as a reference point. But yeah, just trying to make some nice nice volumetric kind of particles and that kind of stuff. Steve GH, the gem master. So let's try a few more. Ooh, look at that. It's pretty interesting. Missing the music? We might bring the music back soon. We'll see. It gets mixed reviews. All right, let's see here. Ooh, you found a face. I feel like that's always a sign of a good render. Is like, especially with clouds and stuff like that, like abstract shapes. If you can imply some forms and stuff with that, it's always nice. This always looks like the witch from like Banjo-Kazooie. Is it Gruntilda? Right? This is kind of like a witch's hat, the big chin, like that a little bit. All right, so let's think about this stuff a little bit more. So yeah, I think this angular direction stuff is going to be a nice composition. Let's just crop in, boom, get a nice direction going there. we have 6.5 million. We can definitely get a little bit more, and we're cropping them to the camera frustum, the camera view. First person camera controls, like in Blender. I've never tried it, but you can kind of build some first person controls. It's definitely not as good as the Blender system. Like, it's not anywhere close to the first person shooter style or whatever. But people have definitely built it. If you look inside of the ChopNet, there's some really cool things you can get with like mouse. You can even use a gamepad, and you can control your camera that way. But it's, like I said, it's a little bit, it's kind of scuffed compared to the Blender. It's not as polished. Oh my God, Shades of Orange, 1 year. Let's go. Thank you so much. Getting the veterans in the chat here. I meant to have some kind of celebratory champagne to pop or something like that, but unfortunately I don't have any right now. All right, let's I think we can add some more particles. I didn't. It's also too early for me to so it's not even 10 a.m. here, unfortunately. So where are we at here? 28 million. Gift. That one isn't as good. Oh yeah. All right. Oof. A little early for champagne, maybe. I guess it's not too bad if you're doing like a mimosa or something like that. Let's just pop this in the renderer and see what we're getting. I think I'm gonna have to redo the lighting. So let's look at our rim light again. Let me just turn off the other camera. And let's turn off the environment light for right now. Okay. Look at that. It's pretty cool. Could be nice. He is smiling. You see another character here. This could be pretty cool if we really kind of backscatter this. Ooh. Let's see what we get with smaller particles. Ooh. Oh, you're on delay? How bad is it? Someone put a 1. Someone typed the number 1 in the chat. See how long it takes you. Such few nodes in this project. 1, okay. So you guys are maybe like 30 seconds behind. Yeah, I don't know. So when you're just exploring and trying out ideas, sometimes keeping it simple, few nodes or whatever, that can be, it's kind of a Zen master approach. It's sometimes less is more or whatever. Tend to get lost in the nodes. All right, let's reduce the opacity. Look at that. Starting to get that volumetric, fluffy kind of look. Ooh. This one's a little too much. The constant vector direction. Yeah, I think it's pretty nice to art direct stuff. And also just to really like control the composition, to give you a graphic look. Like it really helps give you like some nice silhouettes and stuff like that. You guys are looking for the music? I'll have to reinstate that. I turned it off for a little bit. It seemed like the YouTube crowd wasn't certain people on YouTube maybe weren't enjoying it. I don't know. I think this is getting close to where we need to be. Let me just try a couple more things. You found some more some more faces. What is this? This is the horse. You're pretty quick with these paint overs. Yeah, this could be the unicorn or something. Is the elephant man. The dark horse. All right, so I'm gonna try boosting this a few more iterations. The bull. It's almost like a cosmic, I guess because we're on black now, we're closer to like a cosmic type of event. So I think my iterations here, it's getting stretched too far. Let's reduce that. So I was at 7. Maybe 6. So the issue is once you do the constant vector, like the more you increase iterations, you're just smearing things. Sexy particles. It's starting to get nice. I'm just trying to increase the detail a little bit. This could be good. Yeah. Let's add a little bit more roughness. Random vector within cone per. So you could do, you can normalize this stuff. Sometimes I do that. Like if you make this meta import node, then this gives you the total iterations. And you could bring this in to the VOP and like scale everything based off of the total iterations. I'm not I'm not working the best way in terms of like UI or usability. Like if I was to hand this off to someone else, I would take more time to build out controls and stuff like that. I'm not sure exactly what you mean by cone. You're talking about doing some slightly jittered vectors. Turtle to elephant. This is like they've eaten each other. It's almost like a parrot or like a skull or something like that. All right, so I think attribute randomize with a bias. Okay, I see what you're saying. So yeah, that could be cool. I'm just gonna try to get back a little bit. I think this front area here got a little too gnarly. It's almost like a Swiss cheese, or there's like too many holes punched in it. So I'll reduce this roughness. Trying to get a more clean curve here. Oh no, no, it's cool to get ideas. No one should ever feel bad for putting ideas in the chat. Let me zoom out and try to frame a little bit more of these particles in. Idea. How are you doing this? How did you get your colored texts? It's the idea alert. All right. Okay, so I think we're pretty close. Let me just try a few more things here in terms of lighting, and then we'll increase the detail and render off a final frame. So maybe try the fill light again, but just really dial it back and get into the fill. Ooh, you guys are all getting the colored texts. So I think with this fill, I'm just trying to use this to kind of color like the shadows or whatever. Sometimes what I'll do is just turn my light to a very specific color. And you can use that to add a little bit of detail or whatever. Let's try it. So I don't know. It's too many colors now. Yeah, it's if you tried to model a horse, it wouldn't have been as good. I think that's one of the most fun things, like playing around with these noises, is like you can create these really nice abstract complex shapes like by accident or whatever. I think it's kind of cool to have it going off almost into black. The constellation zone. All right, I think we've gotten a little bit more interesting lighting here. So I think let's figure out the depth of field now. So earlier I was turning it on here. Position Z. I think I'm gonna set up an extra image plane. So the reason to do it down here is you can control the sample filtering. So if I just do closest surface, then I should get accurate numbers. Because before the opacity filtering was like messing up the distance. It was like accumulating the value with the opacity. If you set this to closest surface, it will basically ignore the transparency. So if I look at position Z, I press the I key, these numbers should be accurate. So we go back into the color view. If I want my focal plane to be somewhere around here, Let's look back here. So I think somewhere around 9 should be good. Let's do 9. I think I still have it turned on. Depth of field. You might want this a little bit more shallow. The happy accidents. Yeah, for sure. Especially with fluid solvers as well, like doing sims, it takes a lot of time to try different noise seeds, like different forces and different scales of wind or noise to get like just the nice performances. So yeah, I think that this shallow depth of field is starting to work. I don't know if my f-stop could be even lower. Getting very cool fuzziness, or like levels of transparency for sure. Grateful Dead in the background. This could be like the Pink Floyd, like the the planetarium, the Pink Floyd laser show or whatever. The Cosmic Zone. Chuck some noise into velocity. Yeah, that's a good idea. Trying to think what the best way is to do that. So on here, for mantra sampling, we could do velocity blur. And let's just do subtract. So going the final position, the destination, subtraction or subtracted from the original position. This should give you, if you wanted completely accurate velocity, you would want to multiply this by 24, or like the frames per second. I don't want that strong of velocity, so I'm leaving it like a low value. But that number that I put in there, that math or whatever, if we look, let's turn them on. I might have done it backwards. I might be looking at this the wrong way. I think it should be good. Might be backwards. Yeah, we could even do a little bit more. I'm just gonna turn off my update for a second. So I'm gonna Shift R, reverse the order of that, and then you could add an additional curl noise, a higher frequency offset, a little less amplitude to the destination. Is this using pops? Geronimo, welcome in. Yeah, we're almost wrapping up now. So yeah, with that curl noise, it looks like we're getting just a little bit more variation. I'm just doing everything procedurally. So we just have this VOP with the noise functions inside. So I started this off, we're trying to make making some faces. I was looking at a reference of this phone, Galaxy. If you're working, you really want quick art direction. It's sometimes you don't even have time to like tweak simulations. So just working this way, you can get like super art directed results. All right, so we have our velocity, we have our depth of field. So I'm going to try going even shallower with that. And if we look at the particle count, we're at 31. So I'm going to start to crank these numbers. But careful. This will take a little bit of time to cook. It's time to save. Yeah, we might, it's always a good idea to save when you get close to breaking it, when you get close to pushing things to the limit. So I'm at 114 million. We could save. Go up to version 4. If you guys want to break your computers, you can do that. I'm not using Redshift for this one. I switched to Mantra for right now. For the main reason was I know how to make this kind of shader with Mantra that you can do like color attenuation and absorption, and really interesting like subtle stuff like that. So if we look at this is the Mantra shader I've made. It's very simple, but you could basically have a attenuated opacity. So as the light travels through these semi-transparent particles, the color shifts from one hue to another hue. So that's a really cool thing that I don't know how well that works in Redshift. And the other reason is just because I'm rendering like over 100 million particles now. So with Redshift being a GPU renderer, you can't fit as many particles on the GPU. So that's another reason why I'm doing Mantra right now. Yes, I did talk about some optimization stuff earlier. You could go over a little bit more of it. Let me just make this full screen. So when I'm rendering particles like this, if I bring up my Mantra settings, I usually turn off ray variance anti-aliasing. This is like Redshift's extra samples, or I don't remember the exact. Basically V-Ray has a similar setting Arnold has similar settings. It's basically like going to try to sample the light or the refraction to resolve noise that way. When you're rendering so many particles, I think that just working with the primary rays, like the brute force pixel samples, that can be better. So when you're rendering like transparent particles, because they stack up, you don't need to spend as much time like resolving the noise for each particle. So that's why I usually disable that. You could try less stochastic samples, and maybe optimize things a little bit that way. So this is going to re-render stuff in a second. You start to lose like a little bit of accuracy when you do that, but you can speed things up. That's pretty cool. Let me pause this. I think we can go even higher with our camera. So let's go up to 4K. Trying to think if there's anything else we want to change. I might make these particles a little bit bigger. You got to try this. This is the file right here. Your computer might smoke, might light on fire, depending on how much memory and processor and stuff. I'm on a desktop, like a pretty high-end workstation right now. So if you're just on a lightweight computer, you might have to take a walk or wait some time for the values to cook. Yeah, if you're on a desktop that's VFX desktop or whatever, you could 114 million particles. Yeah, you could get you could push this even higher as well, I think. 3080. The 3080 gang. So I increased the size of the particles just to try to pull out like a little bit more detail. If you have the particles that are too small, like you'll lose shadow detail and you'll just get a fuzzy kind of mess. So the more you increase particle size, you can kind of like add some structure back into things. So our depth of field is going. We could try even pushing the depth of field up higher. So let's look at our bokeh. So I actually have some custom bokehs that we could do. Oof. It's really big. Did I make too many? I think I have too many of them. All right. So I think number 2, you can just put this path right in and it should work. This should give you like a wider format. These will become more oval shaped once I re-render it. I'm just going to slam this f-stop to be really shallow. Let's let this cook again and see what's going on. I think we're getting close to running out of time. So this might be the one. This might be the final one, but we'll see. Cool zones are on Monday now. Yeah, my schedule's still a bit of a mess. I haven't clearly defined it, but I'm trying to bounce around between some. We did the last one was kind of a hybrid that was like cool zone, but also somewhat a Vellum, like informative one. It was pretty fun. Yeah, I don't know. We might have cranked it up a little bit. Too much. We'll see what happens. What is cool zone? This is like a name we came up with as a kind of a joke or whatever. But basically, anytime just making Instagram or like style frames, like an abstract. Basically, the only goal of the stream is to make an interesting image. Not really covering a specific task or lesson or whatever, like just chasing a cool image. That's where the idea came from. Kazanas, how's it going? Just got to be on top, waking up, checking Discord. Yeah, I think, unfortunately, because I don't give such advance notice right now. You could turn on the, if you do Twitter notifications, usually I'll put on Twitter right before I go on. The Discord, I'll send a message, and then if you set up your Twitch notifications as well, Twitch can send you like a push notification or email or whatever when I go live. Elaine, thank you for the tier 1. So yeah, it looks like we're starting to get some interesting separation, like of layers or whatever with this, the depth of field. You can also look at just the individual color channels. It looks like this green channel, I'm getting some interesting, more noir kind of setup or whatever. Lots of cores in the render view. Yeah, so I'm rendering this 4K. Then I have the lots of CPUs. Is the Threadripper or whatever. I have no idea about rendering with Karma. This is Mantra that I'm using here. It's definitely slower than Redshift or the other stuff that are GPU-based renderers. But I think it's still valuable to know how to use. So I'm using this 3990X. The beast. Money bags. So yeah, you can do this one as well. Oop. It's too many cores to fit anywhere. Let's get this back. So if you expand this pane down here, you can also look at the different things to play around with. You can also change the exposure and do different gamma settings as well. Unfortunately, like the Redshift post effects is super valuable. Mantra doesn't have anything as interactive as that. You'd have to use like cops or nuke or something at the end of the day to have that much control, but unfortunately you can't do like real-time color tweaks. I mean, you can do this basic color correction, but it's not as nice as the Redshift ones. What about generative art? Would you recommend any resources for pure Vex, Python, C++ workflows? There's actually, for pure Vex, I'd made a YouTube playlist that was named that. I do talk about some generative art techniques. This is a whole YouTube playlist I did. I think if we look here, I called it the Vex Express, but then I was just naming it Pure Vex. This is more technical, so I do go into some stuff like that. I think if you follow this link, you should get it. I don't really get into Python too much or C++ for generating art. I just find it like too slow and too technical. I think that just doing Vex or Vops, you can get really quick feedback without having to like debug and I don't know, doing C++ or that other stuff is like, it kind of gets you out of the like creative mindset, I find at least. So there's also, I forget, it's like, there's a Japanese guy who does Houdini and Grasshopper on YouTube. That's pretty good for, I think this is, yeah. So if you look at I don't know, Junichiro. He has really good algorithmic or like generative procedural art tutorials that are pretty useful as well. He explains the thought process and the mindset as well that is a really good resource. Runs virtual machines with this 500 and a Threadripper. What is the point of doing all the virtual machines? He's multi-threading, like it's like a workaround to do that. So yeah, it looks like we have 10 minutes, 15 minutes left of rendering for this. Should be a nice like 4K image. But yeah, if you guys have any more questions or stuff like that, we'll be wrapping up shortly, but we'll let this render out a little bit longer. This could be cool maybe. Yeah, I really miss like the photographic exposure stuff that Redshift had. It's kind of too bad that you don't have as much flexibility with this render view. This is what we're working on today. You talk about for actual work, for the job. I can't, unfortunately, with NDAs and stuff like that, I can't talk about it too much. Doing a quick rundown on the setup. So yeah, sometimes if you want to just click this to make sure your render doesn't update, like it will still keep going, but you can still change nodes and stuff like that. So yeah, I did do it this way. If you like step through these nodes just from left to right, usually I'll work that way as like I progress. I also saved some other versions, but basically the idea is we just start with this sphere. We fill it with a bunch of particles. In this case, it's like 100 million or something like that. I think this step right here made my computer explode. All right, so let's go back to a lower amount. You heard that, the fan? So we're at the airport right now. It's about to take off. All right, we'll get rid of that fan. Okay, so this is a little over 100 million. So just starting with the sphere, a spherical cloud of particles, and just setting this particle separation to decide the amount. And then I was trying out different methods, but this one I think we're using a ramp. So we just color them based on the distance. So you get a nice gradient. It's very smooth. And then just doing things with a VOP to move the particles around based off like curl noise, directional, constant vector, with the amplitude decided by a noise. So it's kind of like a paintbrush. You could think of it that way, as like we were looking at Krakatoa renders, looking at different references and resources and stuff like that. This one I think had really nice, I never actually watched this, but this one still at least has very nice shading of the particles there that's like very soft and fluffy. Where's that frame from? They teased. I don't know where it is in the video. But yeah, we were also looking at the Samsung Galaxy Here it is. These frames right here. So it's almost like little brush strokes or something like that. And using noise to smear the particles and just trying out different methods. So basically we're just adding noise to the position of the particle. Eventually we did it repeatedly. So like this feedback loop is basically just reapplying the same step to like iteratively move the particles. So if you step them through a noise field or a noise function, you'll get a little bit more detail than just doing like one step through a noise function. That makes sense. We could just play around with this one. This is the constant vector direction. It's a Steve copyright. Basically, we're using a noise and just poking or punching like little holes. So we just smear portions of the particles that way. I think what I eventually ended up doing was like, you do this constant, just a single direction, which is like the up vector here. You could also move it through like a really low frequency curl noise. Function. I think maybe let's just try normalizing this. I might have gotten things a little too out of control. Let's go. All right. So I was also just adding. Whoa. Let's add. So we have a mix of direction and slightly random. So you can kind of smear the particles. Slightly random and also slightly in a direction. All right, I was messing that up. And get some really interesting looks that way as well. Let's clean this up a little bit. So we basically have a slightly like random direction, and then using this noise like an alpha channel or a mask, we're smearing or like only pushing it along that direction. So if we didn't do that, you don't get as interesting of a result, or it's a little bit more like gaseous or whatever. But if you start to really like strip back, you can see a little bit of the original shape here, the original sphere. So you can get some interesting balances of the two things that way. Just scratching. Everyone's just scratching the surface with Houdini. It's like limitless possibilities. There's always different avenues and tricks and stuff like that. I don't have enough time, but like it's always cool to take this as like a base or a source and then run like a fluid sim on top of it, or even get like a pyro sim with some velocities. Like then you can get a really nice mix of like noises and like some nice randomness and things like that. But even this one here, we could be onto something here with this. So let's just move this over. So we're clear that this is a separate idea. Do you stream often? Yeah, I was taking some time off, or unfortunately, like I got pretty busy with work at the start of this year, but I'm trying to get back into it. I think these last few weeks I've been, I think, doing one a week, but I'm trying to get back into like a more regular schedule. We're doing a couple every week, hopefully. But thanks for joining. Thanks for coming in. So we're just doing 1 million with this. We could go up. Start to see what this looks like with more particles. This one could be another really cool one to render. It's almost like a planet, Earth planet getting ripped apart or something like that. After you push, color them based on density. Yes, this is a this is a good technique as well. So this is kind of like a neighbor count. We could just try this if we want to quickly visualize it. Ooh. Oof. All right, I forgot the at symbol. All right, so then I just need these numbers to actually have some amounts. So yeah, you can get like some nice gradients and stuff this way. It's a pretty cool thing to do. You could extract like filaments or really dense regions, and you could start to color things different this way. Ooh. All right, let's try this. So yeah, you can start to get like punch some like intensity. If you're doing like magical effects or spells, this can be really, really cool to do. You can also like rasterize these particles. Where did it go? Rasterize particles. And you can do a similar thing this way. Just have to be careful with these numbers. So this converts it to a gas, to a volume. And then if you just do attribute from volume, this unfortunately doesn't have the same normalization or compensation built in, but you could start to extract. Let me just do it this way, maybe. You can start to get like the denser regions this way as well. You can start to do some blurs or some smoothing operations. You can get lost doing all kinds of abstract stuff. You can even do like analysis, get the gradient. You could color it based on this or do all kinds of fun stuff. Putting the computer to work. Yeah, I'm doing rendering too many things and also generating stuff at the same time. Do you have a dual PC? I do. I'm using a capture card in another computer, so the one streaming is not the one I'm using right now. It's a separate computer. But yeah, this if once you start to get into like 100 million particles, this rasterization can be faster as well, because you're not like running a lookup for every single particle. But yeah, both of these are super useful methods for making spells or energy, like energy shields and that kind of stuff. Yeah, I used to stream on everything on the same computer, and I would, especially with Redshift, or like I would drop frames. My webcam would be at like 5 FPS when I was rendering. I would be like clipping through the wall. But yeah, it looks like we're close to wrapping up. This one, I might play around with it later, but let's go back into points. I think it has some promise for like, this could be an interesting view right here with us. If you want to get rid of this artifact, so when I start with the sphere and convert it into the points from volume, it will get some like faceting. If you want to fix that, you can just go into polygon and then increase this frequency. So then you'll get a really smooth edge. So you get rid of those artifacts or whatever. Let's just play around with this a little bit more. We're almost, render's almost done. This is not too bad. Like, I think even with Redshift, if you're rendering this many particles at 4K, like reasonable noise quality and stuff, it would take a pretty long time as well. Clip through the walls. Start rendering and you start glitching in real life because it was like too many fans going and stuff. All right, so let's see what we can get. So yeah, just playing around with all this stuff, seeing if you can break stuff or how wild you can make it look. Let me see what this one was doing. And then what I did over here with this feedback, I think that's a pretty cheap, like it's a quick way to add more detail. You basically just keep rerunning the noise function and you start to get more like chunks or clumpiness or whatever. So this could almost be like a planet, definitely closer to a planet like being destroyed or something like that, with like these pieces ripping away is really cool. It's like a fist or a punch or something like that. Yeah, it definitely starts to give you more of like a paint stroke. That's originally why I was thinking about it, like a clumpiness about if you take a paintbrush. It's very, very much inspired by these ones. Let's try this. Got sidetracked. Yeah, it's like a mini rebuilding of the effect, I guess. Sorry, I did get a little sidetracked. Do you think this was rendered in 3D? It's quite possible. I think this is Griff, right? He's a really talented designer. You can definitely make these kind of things in 3D. It's very much like almost Photoshop or Illustrator though. Like he's probably using Cinema 4D, I think. And it's usually just like a simple shape with a shader assigned to it. Just like a very simple shader, like a color ramp with some noise or something. And you can get close to these types of effects really quickly. There's like some really talented people that will work in 3D, but the end result, it looks like something almost that they made in 2D or whatever. I was doing something kind of like that. Like this type of thing. So this is a 3D render that was a very simple mesh, but like you can see you get like some interesting gradients and things going on that add like enough complexity. It's nowhere near as good as like the result he was getting. But yeah, that's definitely one thing to look at. Let's take a look. I think his name. It's like Danny Ivan, I think. So yeah, this is another guy who's super talented. Just making these abstract shapes, like very simple mesh with some noise or whatever, but just spending a lot of time getting really good colors, and interesting like folds, maybe applying a couple of different shaders, and you get really nice results. But yeah, I think they're definitely using Cinema or some 3D engine. Like you can't create meshes like this necessarily in Illustrator or Photoshop. But once you assign some interesting shaders to those, or like put a crazy HDRI in there or some things like that, you can get really cool results. So yeah, this is another guy to look at as well. I think Danny uses a little bit of Houdini, but I think he's mainly a cinema artist, if I'm not mistaken. You could look into his, maybe on like his Behance, he mentions the programs he's using. Let's take a look. Cinema, side effects, Houdini. So yeah, people will sometimes combine them, like maybe he generated this mesh using Houdini and then exported it and brought it into Cinema. I'm not exactly sure, but yeah, it's super powerful skill set. All right, so this render is almost done, or is it done? Looks like it's done. It's tricking me. I think it's done. I'm just gonna play around with this a little bit more and then we'll be done for today. Let's do. All right, I think this is gonna be better like that. And let's do that. It's pretty cool. can really get some interesting structures and stuff like that going on. Look at that. Something like that could be pretty cool. It's like a explosion. So yeah, we'll wrap it up. Just move my display flag back. It's like the super intense, expensive render version. Save the file, and that will be it for today. Okay. Make this a higher number. We'll do the scene share. And yeah, do one more minute. Any questions? Yeah, Seagull Rush, as long as it doesn't take too long to answer. Yeah, you have one more question? Bum, 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 bum. Square root of what is it? Oof, didn't work. There you go. You guys got it quicker than me. Do you know how to set up Houdini, read a text file, update real time from it, but doesn't update upon file save? I suppose it should be simple, maybe some Python involved. Yeah, I don't know about real time. You could set a script or run something to cook the node, essentially. Notice, thank you for the Prime. Let's go. Yeah, if you have an Amazon Prime account, you can link it, or you can connect it with Twitch. So Amazon owns Twitch, and then you can use your Amazon Prime to subscribe to me with Twitch Prime, and it's amazing. You get good emotes like you see there. You get all kinds of nice bonuses, effects. You can do Houdinis, Kims. So yeah, if you have an Amazon Prime account, you can link it like that. So yeah, with Python in Houdini, they have a function that will cook or reevaluate an operator. People have set up some things to do this. If you look at the Houdini node, where did it go? Maybe SOP node. Cook, force, ask or forces the node to recook. So based off of like a timer, you could keep calling this and forcing Houdini to update the node. But doesn't update upon file save. There is a like who.hip file that you can use as well. and I think that will let you run a function that saves the scene. There's event callbacks that you can use. Houdini Hell's Kitchen. So here it is, after save, who.hipfile event type after save. So you could trigger an event basically every time you save the Houdini scene. It will trigger that node to recook. Unfortunately, I don't have enough time to build this outer script it right now, but these are the places to look if you're already like experienced with Python. Sometimes people will also make the node time dependent so that it will keep cooking. That might be a quick enough workaround for you. If we look at this L system node, by default, it's not time dependent. So I think one of the things you can do is if you just add like a spare parameter, let's just put it at the top. And I'm just going to leave the name at default. So if you just add a spare parameter and do that, it looks like maybe it's smart enough. It hasn't. Let's get rid of that. Where did it go? Oh dear. All right. Lag hits. Sorry about that. I need to look at my settings. So let's take this generations parameter. So if we multiply this by, let's just do like $FF times 0 plus 1. So the order of operations, this is always going to evaluate to 1, but it's going to make this time dependent. So every frame, this L system will be recooked, or it will trigger it to recook. So this is kind of a hack or like a lazy way, but if you really want to force a node to be time dependent or recooked, this is also one way to go about it. People do this sometimes with like file paths. To force a file path to be reevaluated, they'll append like an empty string or an empty thing like that. The average guy, thank you for the prime. Let's go. So yeah, that's a simple trick for time dependence. But yeah, we'll wrap it up for today. Sorry, I went too long. But yeah, I hope you guys enjoy the files, the image, the testing today.